Welcome. The topic we'll be discussing in this lecture is Bayesian belief network. So basically in the last class, in the last lecture, we have discussed about full joint distribution. But actually there are some issues with full joint distribution. In case of if you want to find the full joint distribution for a list of random variables, then as the number of random variable grows, the table will become very large. As the number of random variable grows, the table will become very large. And specifying probabilities for all possible worlds. So as the table becomes large, there will be different combination of probabilities we have to identify and we have to specify. Basically, this is an unnatural and a tedious task. And apart from that, in the previous class, we have discussed about independence, by which two variables may not be dependent at all. So in that case, their probability, you need not apply any conditional probability on them. So because of the concept of independence and conditional probability, we know like whether a relationship exists between two variables or not. So we need to identify the probability only if a relationship exists between two variables. Otherwise, we need not identify conditional probability. But uh, mm, but in full joint distribution, what we do is we blindly identify conditional probability connecting every variable with every other variable without checking whether they are really dependent or not. So, uh, so when you really know that which variables are dependent and which are independent, that itself will reduce the number of probabilities that need to be specified or that need to be calculated. Okay. The advantage of full joint probability distribution is when you have a table of full joint distribution for a list of random variables, then using that table you can answer any possible question in that given domain. But the problem is, as the number of variable grows, the size of the table will also grow. And identifying the probability and specifying the probability for every combination is really unnatural and tedious. And apart from that, some of the variables may not be really dependent at all. And in that case, if you are for those variables also, if you are identifying the conditional probability, then the result of the conditional probability will be nothing but the same as that of the unconditional probability. But still, we are working out and we are calculating, that is not required actually. So these are some of the drawbacks with conditional, with full joint distribution. Hence, to overcome these issues, that is in a full joint distribution, all the possible combinations of probabilities should be specified. So to overcome this particular issue, we are going for the next type of network, which is called as Bayesian network. Okay. So the Bayesian network, it can essentially represent any full joint probability distribution. So basically, it can do the job of a full joint probability distribution, but it can do it in a very concise way. So this is the core uh, key point about Bayesian network. So Bayesian network can represent any full joint probability distribution, but it can do that in a very concise way. That is, it need not maintain a very big table with all possible combinations. It includes only the necessary things. It avoids all unnecessary combination of probabilities. Okay. So how Bayesian network works, that we'll be discussing with an example. Now, what is a Bayesian network? The Bayesian network is basically, it is a directed graph. So basically, it is a DAG, directed acyclic graph. There will not be any cycle. So it's a directed acyclic graph. Okay, so the nodes in the graph represent the random variable, and these random variable can take either discrete or continuous values. The nodes in the graph represent random variable, and these random variable can take either discrete or continuous value. An arrow from node x to node y. If there is an arrow from node x to node y, then it means that node x is parent of node y. So it's a directed arrow. If you have an arrow from node x to node y like this, then it means that node x is the parent of node y. So basically, this is a DAG, directed acyclic graph. Okay. For every node xi, say this node, if you take this particular node, for every node xi, we'll mention some value p of xi given parent of xi. For example, x does not have any parent. If you say y will have some value which represents like what is the probability of occurrence of this particular uh, this particular random variable, given that its parent has occurred, and what is the probability that this what is the probability of occurrence of this particular event given that its parent has not occurred. So basically, if you see, everything will have two values. What is the probability of occurrence of y given that x has already occurred? Okay, similarly, so it is something like this. So it will have, so basically every node will represent like what is the probability of occurrence of that particular random variable given that its parent has occurred. So let us assume this is x. Okay, so what is the, so basically it is something like this. What's the probability of occurrence of y given that x has occurred? That is one case. Similarly, it will also take the values, what is the probability of occurrence of y given that x has not occurred. Okay, so from this itself you can calculate this. If you know the probability of occurrence of y given x has occurred, then obviously from this you can calculate what is the probability of occurrence of y given that x is not occurred. So this will be nothing but 1 minus probability of occurrence of y given that x has occurred. So the point is, every variable will represent the conditional probability. It will represent the probability of that variable conditioned with its parent. Fine. Now let us try to understand the Bayesian belief network with an example. Assume that you have in your home there is a burglar alarm system is installed, and burglar alarm system is used to identify uh, like if some say that you are locking the home and you are going out, and if your house is installed with burglar alarm system, then it will identify any movements in the house. So basically it will identify thefts. So when you are not in the house, if somebody is moving inside the house, then this alarm, this basically it's a sensor. The sensor will identify it, and it will create some noise, okay. So but here we are considering certain cases. So this burglar alarm system, sometimes it may also create the alarm because of minor earthquakes. Sometimes there may not be any theft. Okay, sometimes the nobody has entered the house, or nobody has entered your house premises, but still the burglar alarm system may create a noise because of minor earthquakes. Okay, now you have two neighbors. One is John, the other one is Mary. So John and Mary has promised to call you when they hear the alarm, because you are not in the home and you have installed the burglar alarm system, and to detect any unusual movements in the house when you are not there, right? But the alarm will not only ring when due to unusual movement, but sometimes it may also ring due to minor earthquakes. And your neighbors John and Mary has promised that whenever the alarm rings they will call you, because you should know, no, okay, something wrong is going on, right? Okay, so and and the other case is John always calls when he hears the alarm. Whenever 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 John hears the alarm, he always calls. But sometimes John confuses the telephone ring with the alarm. So in your home there is a landline telephone, assume, but sometimes John confuses the telephone ring as the alarm, and because of that also he calls, right? So apart from calling for the real alarm, sometimes John will think the telephone are ringing as the alarm, and he may call for that. Okay, and Mary likes loud music, and sometimes he misses the alarm. So Mary used to listen to loud music, and sometimes she misses the alarm, so she may not call. So whenever she listens, she will call, but sometimes she may miss the alarm due to loud music. So given these evidences, given these info as probability, so everything can be represented as a probability. What is the probability of really having some intruder into the house, and what is the probability that an earthquake has occurred, and because of that the alarm has made noise, and what is the probability that John has called because of burglary, and what is the probability that John has called because of telephone bill, telephone ring, so on and so forth. Everything can be represented as probability here. So given the evidence of who has or who has not called, we would like to estimate the probability of a burglary. Okay. So given the evidence of who has called or who has not called, we would like to estimate the probability of burglary. Now this can be achieved by using Bayesian belief network. So whatever our problem, we are representing our problem as a Bayesian network. Okay. So let us assume that the probability of burglary, the chance, this is an unconditional probability. The chance of occurrence of burglary, it does not depends on anything. The probability of burglary is 0.001. Okay. Probability of burglary is 0.001, and the probability of earthquake is 0.002. Okay. So the probability of occurrence of burglary is given as 0.01. Okay. And the probability of occurrence of earthquake is given as 0.02. Now, the alarm will ring whenever there is a burglary, whenever there is a burglary or whenever there is an earthquake. So these two events can either happen simultaneously, or one may happen or one may not happen, or both of them may not happen. So that is represented through a table here. So if burglary has occurred and also the earthquake has occurred, okay, then the probability of the alarm getting ring. So the alarm will ring either due to burglary or due to minor earthquake. So what is the probability of alarm making noise given that there is a burglary and earthquake? So that is 0.95. This data, let us assume that we already know. We are not calculating here anything. So somebody has given the data, we are using that data. Okay. Similarly, what is the probability of the alarm given that burglary has occurred but there is no earthquake? That is, some intruder has entered your home but there is no earthquake. In that case, what is the probability that alarm will make noise? It is 0.94. And what is the probability of alarm making noise given that, what is the probability that alarm will make noise given that there is no burglary but there is earthquake? Okay, there is no burglary but there is only earthquake. In that case, the chance that alarm will ring is 0.29. And what is the probability that alarm rings given that there is no burglary and there is no earthquake? So that probability is very less, it is 0.01. Right. Okay. Similarly, this table, if you see, so alarm depends on two things, burglary and earthquake. And when there is an earthquake, John may call and Mary may call. So we know that John calls all the time when there is an alarm. And also John at times he calls, sometimes he misunderstood sometimes he used to misunderstand the telephone ring as alarm, and because of that also he may call. So what is the probability that John calls because of alarm? So what is the probability that John calls given that there is alarm? Now alarm can be either true or false, right? Sometimes, see, so this alarm value, if you see here, it takes two values, true or false. So when there is an alarm, so really there is an alarm, and what is the probability that John calls? It is 0.90. Because as per our question, whenever there is an alarm, John will call invariably, right? But sometimes John also will call when there is no alarm. So what is the probability that John calls when there is no alarm? So here F means there is no alarm. Alarm value is false. So what's the probability that John calls when there is no alarm? It is 0.05. Right? Similarly, what is the probability that Mary calls when there is an alarm? It is 0.70. And what is the probability that Mary calls when there is no alarm? Right? What's the probability that Mary calls when there is no alarm? It is 0.01. Okay. Now, if you see from all these tables, we can also calculate another value. So what is the probability? So this, if you see, what is the probability that probability of occurrence of earthquake? This is 0.002. So what is the probability of not occurrence of earthquake? Okay. Similarly, you can also calculate what's the probability of not occurrence of earthquake. So the probability of not occurrence of earthquake is nothing but 1 minus 0.002. So it is 1 minus 0.002. which is nothing but 0.998. So this also we may recur. So it is, so let us better write it. So the probability of not occurrence of earthquake is, what is that? It is 0.998. 0.998. Similarly, you can understand what is the probability of not occurrence of burglary. So the probability of not occurrence of burglary is 1 minus 0.001, which is nothing but 0.999. So the probability of not occurrence of burglar is is 0.999. Okay, fine. Now, what is the probability of occurrence of alarm given that there is burglary and earthquake? Both burglary and earthquake are true. Okay. Now, what is the probability of not having alarm? So this is the probability of having alarm when there is both burglary and earthquake happens. Similarly, what is the probability of not having an alarm? What's the probability that alarm does not rings when there is burglary and earthquake both are true? So that is nothing but 1 minus 0.95. Okay, it is 1 minus 0.95, which is nothing but 0.05. So this is 0.05. Similarly, what is the probability that there is no alarm given that there is burglary, but there is burglary, but there is no earthquake? It is 1 minus 0.94. It is 1 minus 0.94, which is 0.06. So this is 0.06. What's the probability that the alarm has made some noise? What's the probability that there is no alarm given that there is no burglary but there is earthquake? So it is 1 minus 0.29, so which is 0.71, right? 1 minus 0.29, so that is 0.71, right? And what is the probability that there is no alarm given that there is no burglary and there is no earthquake? Which is nothing but 1 minus 0.001. It is nothing but 0.999. Similarly, you can also calculate this. So this is what is the probability that John calls when there is an alarm? Okay. So this is what is the probability that John calls when there is no alarm, right? This is no alarm because alarm is false. Similarly, you can also calculate, right? Like what is the probability that John does not calls when there is an alarm? So this is John calls when there is an alarm, 0.90. So what is the probability that John does not calls when there is an alarm? It is 1 minus 0.90, which is 0.10, right? And what is the probability that John does not call when there is no alarm? So this is John calls when there is no alarm. So what is the probability that John does not call when there is no alarm? So it is 1 minus 0.05, which is 0.95. Okay. Similarly, you can calculate for this also. What's the probability that Mary does not calls when there is an alarm? What's the probability that Mary does not calls when there is an alarm? Which is nothing but 0.30. Okay. And what's the probability that Mary does not calls when there is no alarm? Right. So this is nothing but 0.99. Okay. So these values also required to understand Bayesian network. Okay. Fine. Now let us try to answer a question using Bayesian network. What is the probability that the alarm has sounded, but neither a burglary nor an earthquake has occurred, and both John and Mary called? So how would we answer this question? Here the question is, what is the probability that alarm has sounded? So alarm has made a noise, okay, but neither burglary nor an earthquake has occurred, and both John and Mary has called. So what is the probability that alarm has occurred and John has called and Mary has called, okay, but there is no burglary and there is no earthquake? So this is the question, right? So So the question is, so this is our network. So what is the probability that alarm has made noise, John has called, and Mary has also called, but there is no earthquake, but there is no burglary, and there is no earthquake, right? Now, how will we solve this equation? Now, if you see, what is the probability of occurrence of alarm? The probability of occurrence of alarm, it depends on what? The, the probability of occurrence of alarm, actually, it depends on burglary and earthquake. Okay, but here we are saying that there is no burglary and there is no earthquake. Okay, we are saying that there is no burglary and there is no earthquake, right? So this is basically a conditional probability. So what is the probability of alarm making sound given that, what's the probability that alarm making sound given that there is no burglary and there is no earthquake? This we want to find out first. Okay, so this we have to find out. Then now if you see next, what's the probability of John calling? What's the probability of John calling? So John calls actually depends on what? Here we have confirmed that there is alarm. So we have already confirmed that there is alarm. So what is the probability that John calls given there is an alarm? So the next is probability of John calling actually depends on alarm. So what is the, and also we have in the question it is given that alarm has made sound. So what is the probability that John calls given there is alarm? So that is for J. For M, if you see, what is the probability that Mary calls given there is an alarm? Okay, and the next is actually these two are they don't dependent on anything. See, alarm depends on burglary and earthquake. John calls depends on alarm. Mary calls depends on alarm. But burglary and earthquake actually they don't depend on anything. So the probability of not having a burglary is nothing but the probability of not having a burglary. That's it. And the probability of not having earthquake is nothing but probability of not having earthquake. That's all. Okay. Now let us fill the value for this. What is the probability of alarm given there is no burglary and no earthquake? So refer this table. What's the probability of alarm given there is no burglary and no earthquake? The value is 0.001. So it is 0.001. Then what's the probability that John calls given there is alarm? The probability that John calls given that alarm is true is 0.90. So this is 0.90, right? And what is the probability that Mary calls given there is alarm? The probability that Mary calls given there is alarm is 0.70. Is 0.70. Okay. And what's the probability that burglary has not occurred? The probability of burglary not occurred is 1 minus 0.001, which is nothing but 0.999. Okay. So it is 0.999. And what's the probability that earthquake has not occurred? So this is nothing but 1 minus 0.002, which is 0.998. It's 0.998. Okay. Now let us calculate this. So what we are supposed to do, it is so it is 0.01, yeah, 0.001 into 0.90 into 0.70 into 0.999 into 0.998. Okay, so what we are getting, it is the answer is 0.000628. 0.000628. Okay, so this is the probability of occurrence of this particular event, right? So yeah, our answer is correct. So this is what the answer is, 0.000628. So with this, so this is the probability of the case that there is an alarm but there is no burglary and there is no earthquake, but John has called and also Mary has called. The probability of this case is, it's very less, actually 0.00062. right? So similar questions you can answer. Similarly, other questions you can try out, right? What is the probability that alarm has sounded, but there is burglary? But say there is burglary, but there is no earthquake, and John has called and Mary has called, right? And what is the probability that there is no burglary, but there is earthquake, and John has called and Mary has called? Or what is the probability that there is burglary and earthquake? Okay, there is an alarm, there is burglary and earthquake, and John has called and Mary also called. So accordingly, you can fill up the appropriate variable and you can find the solution, right? We'll discuss one more example here. What is the probability that John called? This is another question. What is the probability that John called? So here we are not using multiple variables. So when you are taking multiple variables, it becomes actually easier because we know that which variable dependent on which variable, and we can sort it out. But in this case, we are only asking what is the probability that John calls. So the question is just P of J. The probability that John calls is equal to what? Now John calls depends on what? Alarm. So John calls depends on alarm. But that doesn't mean that John calls only when there is alarm. Sometimes when there is no alarm also John calls. Okay. So the probability of John calling is probability of John calling is probability of the probability of John calling is nothing but probability of John calls given there is an alarm. Okay, probability of John calls given there is an alarm into probability of occurrence of alarm, right? Plus probability of John calling plus probability of John calling given there is no alarm into the probability of not there is no alarm, right? See, this is how this equation actually you should remember. So here actually the John calling depends on only alarm, so that we are using conditional probability that John calls if there is an alarm multiplied with the probability of alarm into plus the John calls when there is no alarm multiplied with the chance of not having an alarm. Okay, so if there are 2-3 variables involved, then for all the variables you have to write like this. Okay, so that you should remember. If there is multiple variables involved, then for all those variables actually this type of equation you have to write. Say for example, probability of John calls actually depends on two parameters A and B, right? Then instead of this equation will become something like this: probability of John calls given A has happened, and what is the probability of A, plus probability of John calls given that A has not happened, and what is the probability that A has not happened, plus probability of John calls given that B has happened, and what is the probability that B has happened, right? And probability of John calls given that B has not happened, and what is the probability that B has not happened, right? So on and so forth. But in our case, the probability of John calling, it depends only on alarm, nothing else. So that we are writing this equation like this: the probability of John calls given there is alarm multiplied by the probability of having an alarm, plus probability of John calls given there is no alarm multiplied by the probability of not having an alarm. Okay, now from this table we can identify what is the probability that John calls given there is an alarm. Probability of John calls given there is an alarm is true, is 0.90. So this is 0.90 into probability of A, plus similarly probability of John calls when there is no alarm. Probability of John calls when there is no alarm. So the alarm is false here. When there is no alarm and John calls is 0.05, right? So this is nothing but probability of John calls when there is no alarm. Probability of John calls when there is no alarm is nothing but 0.05. Okay, and multiplied by the probability of not having an alarm. Probability of not having alarm. So this is A, probability of no alarm. Okay, now 0.90 into what is the probability of occurrence of alarm. The probability of occurrence of alarm, now that depends on these four things. That depends on burglary and earthquake. Okay, so this is something like this. So the probability of having an alarm when there is a burglary and earthquake, okay, right, into the probability of having burglary and earthquake, right, plus the probability of having an alarm when there is burglary but there is no earthquake. Okay, when there is burglary but there is no earthquake, into the probability of having an burglary but there is no earthquake, plus the probability of having an alarm when there is no burglary but there is an earthquake, into the probability of having no burglary and earthquake, plus the probability of having an alarm when there is no burglary and when there is no earthquake, into the probability of uh, having no burglary and no earthquake, right? So this is the probability of A. The probability of A actually depends on this thing. Similarly, plus 0.05 into the probability of not having an alarm, also the same thing you have to write. The probability of not having an alarm given that there is a burglary and earthquake, right, into the probability of having a burglary and earthquake, plus the probability of not having an alarm given that there is burglary and no earthquake, and the probability of having burglary and no earthquake, plus the probability of not having an alarm given that there is no burglary and earthquake, and the probability of having no burglary and earthquake, plus the probability of not having an alarm given that there is no burglary and no earthquake, into the probability of having no burglary and no earthquake, right? So this values we have to find out to sort out this. How we will find out now? So if you take this probability of having an alarm given there is a burglary and earthquake, probability of having an, so that we can find this from this table, probability of having an alarm given there is a burglary and earthquake, that is 0.95. So this is nothing but 0.95. Now what is the probability of having burglary and earthquake both? So the probability of having burglary is 0.01, earthquake is 0.0002. This is 0.001, this is 0.002. So the probability of occurrence of both is nothing but 0.001 into 0.002, right? So it is 0.001 into 0.002, which is nothing but 0.505, right? So this is nothing but 0.5502. Okay. Now, what's the probability of alarm given there is a burglary and no earthquake? 0.94. This is 0.94. And what is the probability that of having a burglary and no earthquake? So no earthquake, what's the probability? First of all, no earthquake is nothing but 1 minus 0.002. So no earthquake is 1 minus 0.002, which is 0.998 into 0.001 into 0.001, which is nothing but 0.000998, right? So this is 0.000998. Now, similarly, what is the probability of alarm given there is no burglary and earthquake? No burglary and earthquake is 0.29. And what is the probability that no burglary, probability of not having a burglary and earthquake? Not having burglary is 1 minus 0.001, just 0.999, right? Just 0.999 into 0.002, which is nothing but 0.001998. This is nothing but 0.001998, right? Now, what is the probability of having an alarm when there is no burglary and no earthquake? So this is 0.001. 0.001. And what's the probability of having no burglary and no earthquake? This is unconditional probability. What is the unconditional probability of having no burglary and no earthquake? So no burglary is nothing but 1 minus 0.001, which is 0.999, and no earthquake is 1 minus 0.002, which is 0.998. So 0.999 into 0.998, which is nothing but 0.997002. So this is 0.997002. Similarly, we have to find out this. What's the probability of not having an alarm given there is a, what do you call, given there is burglary and earthquake? This is 1 minus 0.95, which is 0.05. Okay. So this, similarly, this also, the probability of not having alarm given that there is a burglary and given that there is burglary and no earthquake, this is 0.06. What's the probability of not having an alarm given that there is no burglary but there is earthquake? This is 0.71. What's the probability of not having an alarm given that there is no burglary and no earthquake? This is 0.999, right? So from this table we have to take. So the probability of not having an alarm given that there is a burglary and earthquake is 0.05. 0.05. Okay. The probability of having burglary and earthquake, this already we have calculated. This is 0.01 into 0.002, which is nothing but 0.502, right? Then what's the probability of not having an alarm but there is burglary and no earthquake? This is nothing but 0.006. 0.06. Okay. Yeah. So what's the probability of not having an alarm given that there is a burglary and no earthquake? This is 0.06. And what's the probability of having burglary and no earthquake? Having burglary and no earthquake is having burglary and no earthquake is nothing but the same thing, 0.94. Okay, 0.94. And what's the probability of not having an alarm given that no burglary and there is earthquake? 0.71. This is 0.71. And what's the probability of not having a burglary but there is an earthquake? Not having burglary but there is earthquake, 0.001998. 0.001998. And what's the probability of not having an alarm given that there is no burglary and no earthquake? This is 0.999. 0.999. And what's the probability of not having an burglary and no earthquake? No burglary and no earthquake, 0.997002. 0.997002. So now we got all these values. Now just multiply those values and add, right? So when you do this, you will get this as the output, 0.0521. So this is the answer. So this is the probability that John calls. Okay. So whatever we have discussed, that's what written here. Probability John calls given that there is an alarm into probability of alarm plus probability of John calls given there is no alarm into probability of no alarm. Probability of John calls. Probability of alarm is what? Probability of alarm given that there is a burglary and earthquake into probability of having a burglary and earthquake plus probability of alarm given there is no burglary but there is earthquake into the probability of having no burglary and earthquake plus probability of alarm given that burglary and no earthquake into the probability of having burglary and no earthquake plus probability of having an alarm and no burglary and no earthquake into the probability of having no burglary and no earthquake. Similarly, you should also do for probability of having not probability of not having an alarm, right? Okay. So this is how Bayesian network helps us in answering these questions. So now you can work out for other things also. You can work out like what is the probability that Mary calls, what is the probability that John does not call, so on and so forth. Fine. So let us stop here for today's session. Thank you.